Good day, Prof. This is my final presentation. Today, I will be discussing key concepts in computing, how the CPU works, the evolution of processors, an overview of the GPU, and the operations and programming of the SAP1 computer. These topics are fundamental in understanding how modern computers function. So let's get started. If you do not know much about them, CPUs can be really confusing, but don't let their small size fool you. These things are extremely powerful. We are going to go through all aspects of a CPU and how they work. Cores and threads are talked about a lot when trying to pick up a CPU. A single core CPU would only be allowed to work on one task at a time. But now, even the lower end desktop CPUs on the market now have at least 4 cores, so it can work on multiple tasks at one time. So this means that a 4 core processor can perform 4 tasks right now. Not exactly in modern day. These cores use simultaneous multithreading, which allows one core to split into virtual cores, another term for this is threads. So essentially, a 4 core CPU can run 8 single-threaded tasks without losing any performance. But Intel further complicated things by releasing efficiency cores last year with their 12th gen CPU. This new type of core focuses on taking the load off traditional performance cores efficiency. Efficiency cores do not utilize multithreading or as Intel likes to call it hyperthreading. In basic terms, a performance core is clocked higher and is focusing on Call of Duty, while an efficiency core is clocked lower and will focus you on Discord. It's a little more complicated than that, but you can get the point. This has allowed Intel to increase its core count compared to AMD and keep power usage down. But what does it mean to be clocked higher and lower? And what is a gigahertz? A CPU is made up of base clocks and boost clocks. A base clock is the speed at which all cores in a processor are able to run. So a base clock of 4.7 gigahertz can handle up to 4.7 billion cycles per second. Whereas if it has a boost clock of 5.3 gigahertz, it now can achieve 600 million motorcycles per second. But it will only utilize this if it's an intensive task like rendering or gaming gigahertz. CPU running at a 4 gigahertz made 10 years ago will be greatly outperformed by a modern CPU with the same clock speed. This is not only due to the more cores and threads we mentioned earlier, but other improvements like efficiency. These newer processors require fewer instructions or cycles to execute the same instructions. Efficiency is greatly increased with CPU cache. This is used to decrease the time and energy to access data. So the bigger the cache, the better the performance with that. Out of the way, the next thing you need to know before buying a CPU is the labeling system. Both the main companies use Intel has a large variety of different CPUs, ranging from best to worst. And depending on the year it was released, they have different generations. This is displayed by the first two numbers. So the i3-31 is Intel's 13th generation process for AMD. It follows the same principle, both a lot less variety. The Ryzen 7 6 is part of the 7000 series processors aside from the base version Intel. And AMD have a suffix on some processors Intel's means it needs a GPU and K means it's overclockable with the right motherboard. For AMD, X means higher performance and G means it has internal graphics. There is more for each, but these are the most common. Here are some of the CPUs we recommend for more budget computers. And The CPU, or the Central Processing Units, is the brain of the computer. It processes instructions and carries out computations. The main components of a CPU include: first is control unit, directs operations inside the CPU. Arithmetic logic unit, performs mathematical and logical operations. Registers, small, fast storage areas for immediate data access. Cache memory, a high-speed memory that holds frequently accessed data. Clock, synchronizes all CPU operations at a speed measured in gigahertz. Example: every operation inside the CPU follows the fetch, decode, execute cycle. First, the CPU fetches the instruction from RAM. Second, the control unit decodes it to understand the operation. Third, the ALU performs the addition. And fourth, the result is stored and displayed on the screen. That is how a CPU processes instructions efficiently. The evolution of CPUs. Over the years, CPUs have evolved significantly. Let's take a quick look at the key milestone in CPU development. Early CPUs in 1940s to 1950s, the vacuum tube era. In the 1940s, the first computers used vacuum tubes to process data. A famous example is the ENIAC, stands for Electronic Numerical Integrator and Computer, which was massive, consumed a lot of power, and was highly unreliable. These early CPUs could perform basic calculations, but they were slow and prone to failure. Next is the transistor era in 1950s to 1960s. Smaller and faster. In the 1950s, transistors replaced vacuum tubes. Transistors were smaller, faster, and more reliable. This breakthrough allowed computers to shrink in size and become more efficient, leading to the development of mainframe computers. Next is integrated circuits. In 1960s to 1970s, the first microprocessor. The next big leap came with integrated circuits in the 1960s. Instead of using individual transistors, ICs combined multiple transistors on a single chip. In 1971, Intel released the Intel 4004, the first commercially available microprocessor. This tiny chip had all the core CPU functions and paved the way for modern computing. And the last one is advancements in microprocessors in 1980s to present. Power and performance. In the 1980s, we saw a huge improvements in CPU design. The Times 86 architecture, introduced by Intel, became the industry standard for personal computer. Over time, CPU became faster and more efficient. Thanks to innovations like pipelining, it is allowing multiple instructions to be processed simultaneously, and caching, speeding up data access, and multi-core processors. It is modern CPUs like the Intel Core i9 and AMD Ryzen. Now, we have multiple cores, meaning they can run several tasks at once. This makes them perfect for gaming, video editing, and AI processing. To recap, CPUs have evolved from vacuum tubes to transistors, then to integrated circuits, and now to powerful multi-core processors. These advancements have made computers smaller, faster, and more powerful than ever before. And that is how we got from room-sized computers to the smartphone in your pocket today. Overview of GPU. Now, let's talk about the Graphics Processing Unit, GPU. Well, the CPU handles general purpose computing tasks. The GPU is designed for parallel processing, making it much faster for specific tasks like rendering graphics and AI computations. Key functions of a GPU. Rendering generates images, videos, and animations. Parallel processing executes thousands of operations at once. Machine learning and AI used in artificial intelligence training models.